You guys, welcome back to my YouTube channel. Um, Today we'll be dealing also with Mechanotechnics, right? N6. This is cone clash. This is example 2. But then here is written 1.9. First, you can watch the one that is written 1.8. The previous one is written 1.8. You can check it, but will be written example 1 on my title. I will write it example 1 because it's the second video that I've just did for cone clash. Previously I've been doing friction clash, right? So without wasting of the time, guys, please subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. If you found my video helpful, feel free to like and just subscribe and share to your fellow classmates. All the best. Okay, let us indulge in this example, right? We have given here a conical clash transmit 220 Newton meter, right? This is just a torque. Newton, anything that is measured in Newton per meter is simply a torque. There is no other thing there. Then the surface width, we have given a width which is W. We'll discuss about this. They've given us it's 72 millimeter, and it has included cone. Remember, it's supposed to have same, not included. It's supposed to have a semicolon. So if it's included, this angle will divide by 2. Remember, do not forget that. The outside diameter you've given and the coefficient of friction. So but assuming uniform weight theory, we know uniform weight theory does not change. Calculate the following: the inner radius of the clash. Okay, it's fine. I can quickly just grab the data. Can grab the data there. Some data for you guys. What is data? We have torque, which is 20 Newton meter. Then we have again width, isn't it? Which is 72 millimeter. 72 millimeter, and we have included angle. Okay, we have a diameter. Let me just say that diameter, which is I like to, okay, 360 millimeter. The included angle, angle there, which is 29. So it's supposed to be semi angle, but then let us divide this by 2. If we divide this by 2, it will give us what? 14.5, right, degrees. So what else we have? Coefficient of friction to 0.3. What else do we have? Okay, this is supposed to be radius. Remember, we're dealing with radius here. So I can divide this by 1000, also divide it by 2. If you divide this by 1000 to become in meter and also divide it by 2, you're supposed to get this to be 0.18 which is radius, remember. So this is what we have. So question 1, they said we should calculate the inner radius, which is R. We want that. How can we find that? According to what we have given here, to the formation that you have given. Remember, dealing with we have the width now. If you are given the width, remember this is a cone class. We're supposed to use your structure, that triangle. Oh, sorry about this. What I'm doing. Supposed to use your triangle, isn't it? Isn't it like I'm terrible? Your triangle there. Remember, here we have on hypotenuse, we have the width. Here we have what? Our angle. Here we have R. minus r, isn't it? So we have two things. We have opposite side and the hypotenuse. What is that? Is simply what sine, you have this angle, sine of that angle, isn't it? Sine is what is opposite, whereby opposite is r minus over hypotenuse, which is width. So actually the formula you're supposed to know is this one. If you can know that formula, there will be no need to use this thing. That is the formula you're supposed to use. Actually, you must know when you have a width. So yeah, we have this thing. So they say they want what? The inner radius, whereby is this little r here. So okay, what can we do now? It's fine. We do our things. Okay, sine r minus width, our angle we have it there, will be 14,5 degrees. Big R, outer radius we got is 0,18 minus r, we don't know. What about the width? Is there? Let us divide 72 millimeter. So let us divide that 72 millimeter by 1000. If you divide 72 millimeter by 1000, you'll get 0,072, right? To millimeter. Then supposed to calculate r. We want that, so simply multiply there. We'll have 0,072 sine is equal to 0,018 minus r. Then mathematically, I want this to become positive. I will take it to the other side. Then I take this one to the other side. So this is simply your maths, guys. I will have positive r this side. Then I take all of this to the other side. Then we'll be left with 0,018 minus 0,072 multiplied by sine 14,5 degrees. Then what will be the value of r? What will be the value of r there? Oh, sorry. R is not, you make you do not, sorry, here it's a mistake. As you can see, this one is supposed to become is 0,18. Here I've just realized, you see, is 0,18, not 0,00 minus r, which is fine. This will be 0,18 only. So yeah, if you punch this, what can you get there? I just got 1602 meter. Then if you want this to become in millimeter, you can multiply this by 1000. Then it will be 162 millimeter. Then they say they want what? The inner radius of the clutch. Then they found the inner radius of the clutch. That is it. This is what they wanted. But you know, must know even the outer diameter. For argument's sake, if you wanted to calculate outer diameter, you're going to multiply by that. Whereby if you multiply will be 324 millimeter. For argument's sake, if they wanted you to calculate the inner diameter. But no problem. So number 2, the axial force required to engage the class. We know that, we have two special formulas. Now we have two special formulas for F engaged. We know that this is supposed to be equals to axial force into 1 plus coefficient of friction over tan, right? But F main is this one, the minimum force. F main is F, like this, but the difference will be here. Here will be minus. So yeah, but however, we won't use this one for now. This is F main. But what we'll use, I just say to remember that we'll use this one. This is the formula we'll apply there for F engaged. Our F engaged is that what we'll use. So for us to find this, as you can see, we're supposed to have axial force, then we'll be done. But because already we have the angle, we have coefficient of angle, what is limiting us is this guy, axial force. Do we have axial force? We don't have, we are not given here the axial force, but we've given what? The torque. Let us take advantage of this torque. Of that torque we've given there. Can take advantage of that torque because we know the torque is equal to coefficient of friction multiplied by axial multiplied by Rf over sine alpha. Do not forget, this one is a cone clash. We use this one. Do not use the torque. Do not use this torque. We don't have the one for frictional clash. Do not use this one. But this will be wrong. No longer using cone clash. We are using this one. So we've given the torque, want this. If we can make that the subject of the formula, I multiply there. I will have T sine into, then I divide by these two with coefficient of friction multiplied by RF. This is what you have, buddy. So torque is 220, isn't it? Right. Yes. I saw that it was 220 multiplied by sine. I remember the angle here was 14,5. Hopefully you remember this. Coefficient of friction, I still remember it was 0,3. This is RF, right? Do not make mistake. It's RF, is not for the radius. This one determines whether we're dealing with what. It's either we're dealing with uniform wear or we're dealing with uniform pressure. So what is our RF? Let's check. What is that? Oh. Mm. Mm. um okay, let's assume uniform with your Y. What did I'm tired. Why I'm taking time to see this? Imagine I was busy scrolling, was busy checking here on this screen. I was not seeing here. Assume uniform Y. Maybe I'm tired. Why so it's uniform Y, as you can see. Since it's uniform Y, this will be R over 2. So RF will be that outer radius multiplied into inner radius. Hopefully you know that outer radius. What is our outer radius? Is the one that you've been given, which is 0,18 plus the one that you've calculated, which was 0,162. I still remember. Divide this by 2, we'll get that. What will be this guy there? 0,171 meter. So yeah, multiply here by 0,171. So now it's left for you to punch this and have axial force. What will be our axial stuff here? Punch. If I punch all of this guy here, let me check. On a pan. Okay, that guy give me 1073. 1073 comma 5 173 comma 754 Newton is this body here. So I have this guy now. So since I have this guy, we know that F engage, now we are safe, will be F axial multiply into 1 plus coefficient turn, like that. So F engaged, our axial there, now we know it's 1073 comma 754 into 1 plus coefficient of friction 0,3 into tan 14,5. I remember this. Yeah, the coefficient of friction, it was 3, ne? Yeah, it was 3. So you can check 3. Radius was 14, the angle was 14,5. It was 14,5, or I'm wrong. Yeah, it's 14,5. So yeah, if you punch this guy, F engage, supposed to get that. This body here would be simply equals, if you punch this, the whole of that, supposed to get this guy will give us what? 2319 comma 3,324 Newton. This is that guy there. So we have this guy. Now the smallest force required to maintain this, it's a main to maintain, smallest force required to maintain, to maintain engagement. So you must know that the smallest force is this one. Now will become F main. Maintaining, isn't it? It's F main. You are maintaining will be 1, but the difference is here. This would be minus over turn, whereas that one, the other one, is plus. The difference is that. Then we know that F is this, we have this is the same one. We'll use the same stuff here. It's still the one that we have. We'll only change the sign. Suppose there will be minus, is what will change is only the sign there, nothing else. Still have that. Simply change the sign. Now it become minus. Everything remains the same. Simply change the sign. Yeah, it's a matter of changing only to minus the sign there. Punch that. We got negative 171,816 Newton. Do not be afraid of this negative. This show this clash is the self-locking. It's a self-locking clash. Self-lock. You can say self-locking. It's fine. That negative indicate that it's a self-locking. So number 4, the maximum pressure on the plate. Hopefully you remember your stuff. That F max, also this, it's a one and the same thing, but will differ with R. Remember, this will be F axial over 2 pi R into R minus R, like this. You see, when it's a maximum, we have R, the small r outside, But if it's a P minimum, the difference is the one and the same thing, but the difference differs here. We'll have big R instead of small r. You see, the difference is here. Between this, must be very careful. Maximum pressure and minimum pressure, the difference is between only this R. This will be small r, this will be big R. Do not make a mistake about that, right? So we have asked maximum, not min. Here is the maximum. The axial, we've calculated it. There, remember, it was the one that you've got, isn't it? 754 2 pi. Our r, it was 0, 162. Then big R, 0, 0.18 minus the small one, which is 0, 162. So yeah, if we punch this, what will be P max? 58,605. Remember, pressure just converted it to kilopascal. So yeah, this is what you're supposed to know, guys. So thank you guys for watching. Subscribe to my YouTube channel if you found this lesson helpful, and share it to your fellow classmates. Thank you guys.